Hello Math 130 students, we are going to pick up on page 1, section 7.1. We are going to be solving quadratic equations using the square root method. Remember, the quadratic equation is in the form ax squared plus bx plus c is equal to 0. So this is the general equation that we've been using. Remember, when we are factoring, we use the AC method. It comes from the coefficients. So we want to make sure that we are familiar with this type of equation. So here, we're going to deal with the square root property. If we have an x squared equal to some real number, then what we do to undo that square is we square root it. And when we square root it, we have to do the plus or minus. So notice that whenever we square root, we have this plus or minus. So the examples below. We're going to solve using the square root property. So for number 1, t squared plus 3 is equal to 27. So the first thing I'm going to do is I'm going to subtract 3 from both sides. So now that I have t squared isolated, so now 27 minus 3 is equal to 24. From here, since it's a square, this is where the square root property comes in. I'm going to square root both sides, and because I'm square rooting both sides, I have to do the plus or minus. So now I'm going to have t is equal to plus or minus the square root of 24. And remember, we can simplify that square root of 24. Here, if you remember, 24 can be written as 4 times 6, so that's 2 times 2. So you can think of it as 2 squared times 6. So t is equal to plus or minus the square root of 2 squared times 6. And now, because I have a square and a square root, that means it can come out of that square. So now I have t is equal to plus or minus 2 square root 6. And that will be my final answer. Now for number 2, I'm going to subtract 11 from both sides. So now I have my x squared is equal to a negative 11. Again, even though it's negative, I know that I'm going to have the square root of negative 1 is equal to I, right? That's going to be my imaginary number. So if I have x squared is equal to a negative 11, then to undo the square, I square root both sides with that plus and minus, so that that square root on that square cancels out, so that x is equal to plus or minus the square root of negative 11. And like I said before, whenever I have that negative inside that square root, it turns into that I. So x is really equal to plus or minus I square root 11. And so that ends up becoming my final answer. For number 3, we have fractions, which is fine. We can deal with fractions. The first thing I want to do is isolate the y squared. So I'm going to subtract 100 from both sides. So now I have my y squared over 4 is equal to, and on your calculator you can do 201 divided by 2 minus 100, and you get 1/2. Now, to get the y squared by itself, I'm going to multiply it by 4 over 1, so I can cancel out the numerator and the denominator. So I get that y squared isolated. And of course, I can see here that 2 can go into 4 twice. So now I have y squared is equal to 2. And to undo that square, I'm going to square root both sides. And don't forget the plus or minus. So now I have that y is equal to plus or minus the square root of 2. And that ends up becoming my final answer. So just because they're fractions, it doesn't mean that you should shy away. You guys are always allowed your calculator. So if you need to, use it. Now for the next section. or for number 4, I'm going to add 220 to both sides. Remember, your goal is to get that z isolated. So negative 196 plus 220 is equal to 24. And so I'm going to divide by 6 on each side, so that z squared is equal to 24 divided by 6, which is equal to a 4. Now I get to square root both sides, and don't forget the plus or minus, so that z is equal to plus or minus the square root of 4. Well, since that's the case, well then z is equal to plus or minus 2. So really, z is equal to a positive 2, and z is equal to a negative 2. So I could have written my final answer as this, or I could have written my answer as this, as z is equal to 2 and z is equal to a negative 2. That's what z plus or minus 2 represents. It represents the positive 2 and the negative 2. For number 5, what might seem a little bit different is that now we have a binomial term, which is being squared, but it's the same process. We still want to isolate that squared term, so I'm going to add 8 to both sides, so that I have 4n plus 6 squared, and 56 plus 8 is equal to my 64. Now I'm going to square root both sides, so that 4n plus 6 is equal to plus or minus the square root of 64. And don't forget that the square root of 64 is actually 8. So 4n plus 6 is equal to plus or minus 8. Now I'm going to subtract 6. And this is very important. That 6 has to go in front of that plus or minus, so that I have 4n is equal to a negative 6 plus or minus 8. From here, I'm going to divide by 4. And I divide everything by 4. So if I have the fraction negative 6 divided by 4, that gives me a negative 3/2 plus or minus, and 8 divided by 4 gives me 2. So if I have n is equal to a negative 3/2 plus or minus 2, it gets split off to 2 equations. Now I'm going to have that n is equal to a negative 3/2 plus 2. Well, when I do that, I'm going to do that in my calculator. So a negative 3/2 plus 2 gives me a positive 1/2. So that's one of my answers. Now, for my second answer, I'm going to have n is equal to a negative 3/2 minus 2. So, I do the exact same thing, except now instead of a plus, it's going to be a minus. So negative 3/2 minus 2 gives me a negative 7/2. So now I have that n is equal to a negative 7/2 as my final answer. So those are my two answers. For number 6, here I have a trinomial. So I think the first thing that I want to do is I want to set to 0. Since this is a trinomial. So I'm going to add 18 to both sides. And that'll give me the 0. So now I have d squared plus 10d, and 25 plus 18 is equal to 43. So then from here, I want to go ahead and factor. So I said that we can try to factor this, but as I can see, this polynomial is not factorable. So it doesn't mean that I did this problem wrong. It just means that this method isn't necessarily going to be our best route. So I'm going to redo this problem. And I don't want to erase it or kind of, backtrack and, do it perfect from the beginning, because this is how math is. Sometimes you're going to look at a problem and think you're going to do it one way, and then once you get into it, you might find a different method is going to work best. So now I have a new strategy. I'm going to think this is d squared plus 10d plus 25 is equal to a negative 18. So instead of setting it to 0, what I'm going to do is I'm going to factor what I have equal to a negative 18. Well, if I'm thinking about the AC method, I could think of my A as a 1, my B as a 10, and my C as a 25. So I have 25 and the positive 10. So I can have positive 5. That's going to go inside my parentheses. So I'm going to have D plus 5 and D plus 5. Well, this is really saying that I have D plus 5 squared is equal to my negative 18. Now I have that square there. Now that I have that square, now I can square root both sides. So that D plus 5 is equal to plus or minus the square root of a negative 18. And now I can subtract 5 from both sides. So that D is equal to a negative 5 plus or minus the square root of a negative 18. And because this is negative, that's going to be my imaginary. So D is equal to a negative 5 plus or minus I root 18. And let's see if 18 can be broken down. So 18 is 9 times 2, which is 3 times 3. So if that's the case, I can say that this is D is equal to a negative 5 plus or minus I. And for 18, I'm going to have a 3 squared times 2. So it tells me that this 3 can jump out. So I can have D is equal to a negative 5 plus or minus 3I square root 2. And so that ends up becoming my final answer. So usually when we try to factor things, we really want it to equal to 0. But in this particular case, because we're using the square root property, we wanted a square on one side of the equation, and I was able to square root both sides. And that's how I ended up getting my answer. So taking that into consideration, that brings us into completing the square. So completing the square is a particular method that we're really going to have to learn. And this method is going to be really helpful, not only, now for the section where you need to know this method, but later on in chapter 9, where we're going to have to deal with hyperbolas and ellipses and circles. So completing the square is going to be really, really helpful. So we want to make sure that we understand how to do this. So here we are. Here are our steps. Remember that general form is that ax squared plus bx plus c. So those are the coefficients that we're going to pay attention to, the a, the b, and the c. So let's look at example number 1. It says consider this equation. Well, step number 1 says make sure the quadratic is written with the leading coefficient of 1. Well, here, that leading coefficient, we don't have 1. So it definitely defaults to be a 1 when I don't have a coefficient. So perfect. Step number 1 done. Now, step number 2. Rewrite the equation with the constant isolated on the right side of the equation. So here, C represents the constant. So we want that isolated, so we want to bring it over. So here, number 3 is the constant. So since we want to isolate the constant, then we are going to subtract 3 from both sides. That gives me x squared plus 8x is equal to a negative 3. Now for step number 3, it wants us to identify our b value. So if we identify our b value, that's the thing in front of the x, right? So here, the b value is the thing right in front of the x. So here, my b is equal to 8. So if I were to divide it by 2, well, 8 divided by 2 is 4. And if I were to square that, well, 4 squared is 16. So to get from here to here, I divide by 2. And to get from here to here, I square it. Okay? So that's how I get from b divided by 2, and b divided by 2 squared. So now it's going to follow this outline. And remember, it says, well, actually, step number 3 done. I like to check it off. So step number 3 checked off. Now, step number 4, we're going to follow this outline. And it specifically says, careful, the signs depend on the original equation. So we are going to have parentheses squared is equal to plus. And so let's figure out what these things are going to be. So I definitely have the x. That's what I have. Since I have an addition, the addition gets dropped down. And now what goes in here is that b divided by 2 value. That constant that I had, I already have it as a -3. And now I have that b divided by 2 squared value. So now I get to just plug it in from what I have on the left-hand side. So I have my parentheses squared. So that b divided by 2 value is 4, and that b divided by 2 value is a 16. So now I have this x plus 4 squared, and now I get to add -3 plus 16 gives me a positive 13. So now that I'm here, it says to use the square root property to cancel out the degree 2 on both sides. So I'm going to go ahead and do step number 5. So I'm going to rewrite it. X plus 4 squared is equal to a 13. So this is where I square root both sides, and I do the plus or minus. So now from here, I'm going to have x plus 4 is equal to plus or minus the square root of 13. And I need to solve for the variable in step number 6. So in order to do that, I'm going to have to subtract 4 from both sides. So now x is equal to a -4 plus or minus the square root of 13. So I solved for the variable. Now you want to check your solution in the original equation. You want to make sure that when you plug this in, it's actually going to give you 0. And I've checked it, and it works out. So that is going to be my answer. Okay. Now, example number 2, we're going to follow the same process. So I'm going to make sure that this 18m is on the opposite side. So I'm going to have m squared. And I'm going to minus my 18m on both sides. So now I have m squared minus 18m is equal to a positive 63. So now I can tell you that my a value is 1, my b value is a -18, or actually, I really just care about that b value, it's -18. So now if I have my, I'm going to color code it, here we go, b is equal to a -18, there we go. So then my b divided by 2, if I were to cut that in half, it would be a -9. If I were to square that, well, -9 times -9 is a positive 81. So now my outline and since it's a minus, I'm going to bring down my minus sign. And I have my b divided by 2 value. And over on this side, I have my b divided by 2 squared. So now I have m minus my 9, and I have my b divided by 2, which is my 81. So now m minus 9 squared is equal to, and I have 63 plus 81, which is 144. So I am going to square root both sides, so that m minus 9 is equal to plus or minus the square root of 144. And don't forget that the square root of 144 is perfect. That's 12. So m minus 9 is equal to plus or minus 12. And I'm going to add 9 to both sides, so that m is equal to a 9 plus or minus 12. So I'm going to split this up. I'm going to have m is equal to 9 plus 12. So 9 plus 12 gives me a 21 as my final answer. The second answer is going to come from the second part, which is 9 minus my 12. And 9 minus 12 gives me negative 3. So m equal to a negative 3 is going to be my second answer. And of course, you always want to check your solution. So let's try for m is equal to 21. So I'm going to have that I'm checking m is equal to 21 into my original equation. So I'm going to have my 21 squared. Is it equal to 18 times 21 plus 63? Well, 21 squared is 441, and 18 times 21 plus 63 is equal to 441. So that works out. Perfect. Lovely. Now I'm going to check that m is equal to a negative 3. So negative 3 squared is equal to 18 times 3 plus 63. Well, negative 3 squared is 9, and 18 times 3 plus 63 is equal to 117. So look at your answer for number 2. Does it make sense? Can 9 be the exact same value as 117? It cannot. So we actually have to throw that answer out. So the only viable answer, we only have one answer, and that one viable answer is m is equal to 21. For m is equal to negative 3, it did not work out. And you can see that I made a really small mistake that messed me up. M is equal to negative 3, so I have negative 3, but I did not put a negative 3 here now, did I? I should have made that a negative 3. So let's try that again. So I have 18 times negative 3 plus 63. Now that's equal to a positive 9. So it did work out. So when you're plugging in and checking these values, you always want to make sure that you're plugging in the value that you're supposed to. So just missing that negative sign kind of made me get the wrong answer. So m is equal to negative 3 is a good answer. So I do apologize for that, but it's good to know that, mistakes happen when you drop a negative sign. So that was a really good lesson to learn. And even as a math professor, when you drop a negative, which sometimes that happens when you're going too fast, you're not going to get the right answer. So m is equal to negative 3 is the correct answer, and you do get 9 is equal to 9, which is a true statement. So m is equal to negative 3 is a good answer, and m is equal to 21 is also a good answer. So always get into the habit of checking your solutions, because you never know whether or not it's going to work out or not unless you check it. Now for example number 3, Notice how we have u minus 14 and u plus 10. These are not perfect squares, right? It's not a square term. So what I'm going to have to do is I'm going to have to FOIL this out. So I have a u minus a 14 times my u plus 10. So if I were to FOIL this out, I would have my u squared. Now I would have or actually, this is equal to negative 104. So I have my u squared plus my 10u, negative 14u, and a negative 140, all equal to my negative 104. So when I combine like terms, I'm going to have a u squared minus 4u minus 140 is equal to a negative 104. So to get this equal to 0, I'm going to add 104 to both sides. So that u squared minus 4u and a negative 140 plus 104 is equal to a negative 36. And if you guys really like the AC method, that's fine. You can do the AC method. I need two numbers that multiply to negative 36 but adds up to a negative 4. So let's think about our multiples of 36. I have 1 times 36, 2 times 18, 3 times 12, 4 times 9, and 6 times 6 is 36. So which one of these combinations will add up to give me a negative 4? Well, you always try to factor. So none of these combinations are going to add up to give me a negative 4. So factoring is not going to be an option. This is where the AC method really comes into play, because you want to find your solution. You're used to using the factor method and you cannot. So the only thing that you have up your sleeve, your methods, your skill set is going to be to use the completing the square. So I have my u squared minus 4u minus 36 is equal to 0. So I'm going to be completing the square. And in order to complete the square, remember we want to isolate the constant. So I'm going to add that 36 to the other side. So that u squared minus 4u is equal to my positive 36. Here, my b value is equal to a negative 4. So my b divided by 2 is going to be a negative 2. So if I were to square that, that's going to give me a positive 4. So here I have my b divided by 2 and my b divided by 2 squared. So I'm just popping in these values. So u minus my 2 value, and I have my 36 plus my 4. And 36 plus 4 gives me 40. And now I can square root both sides with that plus and minus. So that u minus 2 is equal to plus or minus the square root of 40. And I know that I can break down 40. So u minus 2 is equal to plus or minus 2 square root 10. And now I'm going to add 2 to both sides. So that u is equal to 2 plus or minus 2 square root 10. And so that ends up becoming my final answer. And we still have some more completing the square. What's different about number 5 and number 6 is that now the leading coefficient is not 1. But what we do is we force it to be 1. So in order to do that, that means I'm going to divide every single thing by 3. So I end up getting my x squared minus 2x is equal to, and 216 divided by 3 is going to equal to a 72. So now I know that my b value is equal to a -2. My b divided by 2, well, that would be a -1. And if I were to square that, it's a +1. So now I have this as my minus my b divided by 2 and my b divided by 2 squared. So that b divided by 2 value is your -1. And that b divided by 2 squared value is a +1. So now you have x minus 1 squared is equal to a 73. So to solve this, I'm going to square root both sides so that x minus 1 is equal to plus or minus the square root of 73. And 73 can't be broken down anymore, so I'm going to add 1 to both sides so that x is equal to 1 plus or minus the square root of 73. And that ends up becoming your final answer. Now, what's different about number 6 is, again, that leading coefficient is not 1. So when this happens, your b value isn't very nice. It's going to be a fraction. That's okay. Let's leave it as a fraction. And -155 divided by 5 gives me a -31. So now I have that my b value is a 32 divided by 5. So when I divide that by 2, so I'm going to have my 32 over 5. And then after that, I'm going to divide that by 2, which gives me a 16/5. And if I were to square that value, well, 16 times 16 is 256, and 5 times 5 is 25. So now I have my outline. So I have my b divided by 2 value, and I have my b divided by 2 squared. So I'm just plugging in the values that I've already figured out. So I have z plus my 16/5 squared. And this is, again, you can use your calculator, a -31 plus the fraction of 256 divided by 25, which gives me a -519 over 25. From here, I'm going to square root both sides, so I end up getting z plus 16/5 is equal to plus or minus. And remember with the square root property that I can split this. So I'm going to have the square root of -519 over the square root of 25. The reason that I can do this was listed in the last chapter. And so that negative is going to turn into my I. And the square root of 25 is really just 5. from here, I'm just going to add that 16/5 to both sides. So minus 16/5 to both sides. So that z is equal to a negative 16/5 plus or minus I square root 519/5. And that ends up becoming my final answer. Okay. Well, if you guys have any questions, please feel free to email me or our Math Success Center or our tutor. Thank you.